Alright, so for the practice problems for our test, I'm going to work through these in front of you, and you can use this video on your own at home as well to revisit each of the problems in preparation for our test tomorrow. The first problem that you tackled, and I am operating under the assumption that you have a time on this because you've been provided a time for the best to get this done. The first problem that you tackle says write an equation in vertex form with the vertex of -5 and -3, which is going to be our HK, and the point 1 and -75 is on the parabola. So what I realize right now is that I have the HK values to help me. And I also have an X and Y pair that are on the parabola that I can put into place. And doing that is going to leave me with the ability, using those are going to leave me with the ability to solve for the A value that I can put into this vertex form. We're going to use this point to get to A along with our vertex and then leave it behind to write our equation. So what I've got is -75 equals our unknown A, the X value we're using is going to be 1, minus our H. Now it's minus -5, so that's going to put a 1 plus 5 in our parentheses here, and then plus K, in this case our K is negative. The very first thing I'm going to do to solve this equation is just simplify what's inside the parentheses. This is going to be 6 to the second power. 6 squared is going to give me 36. I'm going to take that 36 and put it in front of the A and bring down my -75, my equals my or my -3. Got ahead of myself because the reason why I said plus 3 is because I'm going to do that being subtracted. I'm going to add it to both sides. And that's going to give me -75. I'm down 75, I add 3. I've got a -72, resulting from -75 plus 3. Now if I undo 2 get A alone, I'm going to have 36, 72 divided, -72 divided by -76, or -72 divided by 36. 36A divided by 36 is going to leave me with A, and I know that 36 goes into 72 twice, and since it was negative, my A is going to be -2. Now, using the A and the H and the K that I pointed out earlier, I've got the ability to write my equation in vertex form. Ignoring the X and Y that I used, it helped me to get what I needed, which was the A, and then I'm plugging those values into the equation. Don't forget that this is X minus -5, that's where my addition came from. This was plus -3, that's why I wrote this subtraction. Now, we're going to use the same idea, and if you need to pause and go back to any parts of these, do so. You're going to use the same idea to help you write the equation for the next problem about an egg launch contest, an egg toss contest. So an egg is launched during an egg toss contest. After 12 seconds, it's 72.8 feet in the air and at its maximum. So what do I know about that then? If it's at its maximum, that means that this is going to be the vertex, the H and the K. They're also going on to tell us that after 15 seconds, it reached a height of 65. So at its max, it was at 72.8 after 12 seconds. And then it came down and was at 65 a few seconds later. So what I got in this pair is just another point, an XY on the parabola that I can use again in order to write an equation for this situation. Now, in order to write my equation, I use a lot of space. I'm going to have to draw a graph of this, but I'm going to go in and use the same structure I did before. I'm going to put a Y equals my unknown A, the X I have minus the H, all that squared plus K. So I'm going to simplify again. This is going to be 15 minus 12 is going to be 3 to the second power, and 3 squared is 9. So now I'm in this position to solve for A. If I do 65 minus 72.8, bring down my 9 and 8 of my equals. 65 minus 72.8 is equal to -7.8. I'm going to divide by 9 on both sides and find out that A is equal to -0.86. It's an interesting A, but there's no reason why we can't have a decimal for an A value. The other thing about this is noticing the A is that, yes, I am coming up with a value that makes sense for the path of an A because it's a parabola that opens downwards. So my equation now, back to the way I finished in the previous problem, my equation is going to be y equals, put my A in, x minus the h squared plus a. So there's my equation to model the path of this A. Now, I have the equation to model this, and the question is what time does the A hit the ground? Because what we know is that the partner completely missed the touch. So the A hits the ground. When is that? So I'm going to use the equation that I just wrote to try to get an estimate. I'm going to put in a bunch of sixes for the A because it was negative 0.86666 repeating. And then x minus the 12 to the second power plus 72.8. When I go and look at a table of values here, let's see. Here's my 15 seconds and 65 for sure. Here's my 72.8 as the vertex. What it was that I had started out with in the beginning. And I want to know when this lands. And you know what? What time did the egg hit the ground? The egg's going to come over and hit the ground somewhere between 21 and 22 seconds. Because somewhere between 21 and 22 seconds is when we get that y value of 0 again. Which means that it's gone up in 100. Now, in order to graph the function, I know I'm going to have time down here in seconds. And I know I'm going to have height over here in feet. And in terms of my time in seconds, it's not going to hit the ground until 22. So let me see if I can. I think I'm reasonably confident that if I go by fives, I'm going to be able to get over here at 22 so I can show where it lands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to go, let's plot some things we had, 12 and 72.8. Now if I've got to get up to my maximum of 72.8, that means that my scale's got to go somewhere to 75. I'm wondering if I skip by 5s. 5, 10, 15, 20, sure. 25, 30, I'm going to get there, 35, 40, 45, 50, 55, 60, 65, 70, this is 80. Now notice, I did go by 5s, but I only wrote down every 10, just so I didn't have a big mess over there. So I know that the maximum was at, let's see, 12 seconds, and I have to take myself up to where 72, I'm going to go grab a couple of values. At 21, let's see, at 21, I'm up at 2.6. So actually, my little estimate that I put there wasn't bad. I'm going to look in my table for some more values that I can put on here, and I'm going to look for some nice equal numbers. And I just wonder, oh yeah, that 15 and 65. 15. Oh, 65. Here we go. 65. I'm up at 15. Bam. So actually, this is not nice. There we go. I'm thinking about the axis of symmetry. I'm going to see 65 over here as well. I know it's going to come down that way. I'm interested in finding out. Yeah, there it was. 9 and 65. Perfect. 9 and 65. At 3, it was at 2.6. I'm going to go over there, 3 and 2.6, because that actually gives me the place to start my parabola. So having my equation, let me go in and grab some different points to help me plot this. Sketch a graph, your sketches, you absolutely should be plotting specific points, not just a nice curve like you see in the graph calculator, use your table. And I got that answer, given calculations, fantastic. Now, try this, the height of a golf ball in feet, t seconds after being hit is given by the equation, and h of t equals negative 16t squared plus 48t. I'm going to put that in using x's and y's, negative 16x squared plus 48x. Maximum height means that, let's see, is this going to open down? It sure is. I need to know how tall it is right here. So I'm gonna go into, oh, this is an interesting one. This is an interesting one. I think we've seen a problem like this before. I can tell that the maximum is gonna be somewhere here between, above, I'm sorry, not between 1 and 2, but above 32. Because there's no way, I'm missing the max. It's somewhere in between 1 and 2. Now, one of the things that I can do is change my table setting. And I did second window to get to this. Table start is when I go into my table, what X value is sitting there. And this change in table, this triangle here means change. And the change in table is going by ones. I'm going to see if I put that at 0.5, if maybe I get closer to finding my max. Check that out. When I get closer to finding my max, or when I get into 0.5, I actually find my maximum right here. What's the maximum height of the golf ball? It's sitting at 36 feet. At what time does it reach its maximum height? And that was at 1.5 seconds. And then the question is what time does the golf ball hit the ground? Well, it starts over at 0, 0. It comes up to 36, 1.5, 36. And then it lands at 3, 0. And so what time does the golf ball hit the ground? 3 seconds. Now, if you don't use your calculator in order to find the maximum and change the table, what you can do is recognize that you can get the vertex of this by using the idea of negative b over 2 times a. And that would be negative 48 over negative 32. And negative 48 divided by 32. I believe is 1.5. Sure is. So my x value of the vertex is 1.5. And I can go back in and use that. Y when x is what time is 1.5. There we go. So I'm going to go to my calculator and let my calculator do that work. Negative 16 times 1.5 squared plus 48 times 1.5. And there's my maximum negative 46 that I got on the table. So that's another method. We've used that. Last but not least, the height of an arrow in feet after t seconds is given. So this is asking some questions about what's going on after 1 second, after 3 seconds. These are x values. What's its maximum height? That's going to be the y value of the vertex. No. What time does it reach its maximum height? That's going to be the x value of the vertex. What is the maximum height? That's going to be the y value of the vertex. And then the domain and range is going to be the x values that make sense. And the range is going to be the y value that makes sense for this arrow. So let's examine a table and see if we can get at those answers. Negative 4.9 x squared plus 20x plus 5 going into my table. Now I'm going to change my table back to going on by ones. I need to oh, interesting. So the x value after, what I can do here, after 1 second, is at 20.1 feet. I'm seeing that in my table. After 3 seconds, it's at 20.9 feet. And I don't see this nice symmetry in my table to get the x and y value of the vertex. So I'm going to go back to the method I used up top. I need to get, well, hold on a second here. I want to do the domain and range while I'm looking at the table. The domain, the x values that make sense. Boy, I can't tell you that I believe that time being anything other than 0. So the domain is reasonable time. For reasonable time, this gets launched at 0 seconds. For reasonable time, this gets launched at 0 seconds. And it is landing somewhere between, it's coming down somewhere between 4 and 5 seconds. From 0 seconds to about 5 seconds. That's reasonable. Now, the y values, I'm going to say the y values then it has to do with the height, and the height of it is going to start out at 0 feet, but the highest it gets, I'm going to have to get that out of that y value of the vertex. That maximum height is going to give me the next value here. So let's find out what that is. X value of the vertex is going to be, now my A is negative 4.9, my B is 20, my C is 5. Negative B over 2 times A. 20 divided by 2 times negative 4.9. I'm getting the x value of the vertex to be 49. Boy, that seems high to me. I'm gonna go back and see what the correct is. I think I did something wrong in my calculation. I must have, because, yep, I know exactly what happened, the way I put it in here. Let me do add another set of parentheses. I knew that was too high. I knew it was up in the 20s from what I had in my calculator before. Here we go, 2 times, I wrapped up another set of parentheses, negative 4.9. That's gonna get it for me. X value of the vertex, 2 seconds. Let's see, a little more than 2 seconds. Sure enough, at 2.04 is where it hits that maximum and then it starts coming down. That makes a little more sense. So, X value of the vertex, what I learned in my calculator was I learned the parentheses on that denominator, and it was 2.04 approximately. So that answers what time does it reach its maximum height, about 2.04 seconds. And what is the maximum height? So now I have to go back in, and I have to say, all right, what is that maximum height when I have 2.04